Here are two implicit differentiation problems. So in class, we did problems like this, and I think it will be useful to do a couple more. So remember that when we're doing implicit differentiation, we want to use a chain rule when we're taking the derivative of y. So the first thing I'm going to do is take the derivative of every single term. So I'm going to take the derivative d over dx of this x squared term. I'm also going to take d over dx of the 7x squared y squared term. I'm going to take the derivative of this y squared, and I'm going to take the derivative of this 4. Okay, so I'm taking it of every single term. So the derivative of x squared is just 2x. Okay, so that's that. Now this part I'm going to put in parentheses or in brackets because we have multiple terms. We have this 7x squared and this y squared. So first, we're going to use a product rule. Okay, so I'm going to leave the 7x squared by itself. Oh, I'm sorry, that's wrong. I'm going to take the derivative of 7x squared. That's going to give me 14x. And then I'm going to leave this y squared by itself. Okay, so I took the derivative of 7x squared, which is 14x. And then I left y squared by itself. Then I'm going to add it to, now I'm going to take the derivative of this y squared. So the derivative of y squared is going to be 2y. But since I just took the derivative of y with respect to x, I'm going to add a dy over dx. Okay, so every single time we take a derivative of y, we multiply by a dy dx. And now I'm going to leave the 7x by itself, 7x squared. And I'm putting this in brackets because we have a minus in the outside and we have to distribute that in the end. All right, now the third term plus d over dx, the derivative of y squared, that's going to be 2y. Since we just took the derivative of y, we're going to multiply by dy over dx. Okay. All right, and then the derivative of 4 is just going to be 0. So all we just did was just take the derivative of every single term, and if you have a y, we're going to put a dy dx after we take the derivative, okay? So now let me move this inside. I'm going to have 2x minus 14x y squared minus, let me move this 2y and 7x squared is going to give me 14x squared y. Then we have a dy dx there. Plus 2y dy over dx is equal to 0. Okay, so now what I want to do, I want to solve for dy dx. So this term has a dy dx and this term has a dy dx. So let me move everything that doesn't have a dy dx. So I'm going to move this 2x over and I'm going to move this 14x y squared over to the other side. Okay, I'm going to do both of them at the same time. Whoops. That looks ugly. So I'm going to have y squared. So this is going to go away. This is going to go away. I'm left with this minus 14x squared y dy over dx plus 2y dy over dx is equal to minus 2x plus 14x y squared. Okay, so now I'm left with the terms that have dy dx, and the way that I'm going to get rid of that is by factoring it out. So I'm going to factor out the dy dx. Okay, and what I'm left with is negative 14x squared y plus 2y equals negative 2x plus 14xy squared. Okay, then all I got to do is just divide by this. Divide by this negative 14x squared y squared plus 2y. Divide by negative 14x squared y plus 2y. All right, and what I'm left with is dy over dx is equal to negative 2x plus 14xy squared divided by negative 14x squared y plus 2y. Okay, this is my final answer. Yes, you can reduce, of course, but this will be okay on an exam where you don't have time to reduce. I would be fine with this. Okay, so the whole goal is just to get dy over dx by itself. So in the end, you should not have any dy over dx in here. You should only have x's and y's. Okay, so let's do a little one that's a little bit more harder. So let's just do this one. X squared cosine y is equal to the square root of x squared plus y squared. Okay, so there's going to be multiple chain rules and product rules here. So the first thing is that I'm going to take the derivative of everything. So d over dx of this thing is going to be equal to d over dx of this other thing. Okay, so I'm going to take the derivative of this, of x squared cosine y and of square root Let me actually change that up. Let me change that to x squared plus y squared to the power of 1/2. Okay, I think that might be better to work with. Okay, all right. Okay, so now let's take the derivative. So here I see that there's two different terms, and when there's two terms, I have to use the product rule. So first I'm going to take the derivative of the first, which is 2x, leave cosine y by itself, plus now we're going to take a derivative of cosine y, which is actually negative sine y. But since we just took the derivative of something that had a y, I'm going to put dy over dx. Because the derivative of cosine y will be negative sine y, dy over dx, then leave x squared by itself. Okay, so that's the derivative of this first term. Now this one is going to be a little bit harder, just a tad. Let's take the derivative of this. The 1/2 is going to go to the front by using the chain rule. Then we have x squared plus y squared in the inside. Since subtract it from 1, that's going to be negative 1/2. And now I'm going to multiply it by the derivative of the inside. Okay, and I'm going to put brackets around this. So the derivative of the inside was the derivative of x squared. That's just going to be 2x. Plus the derivative of y squared. That's just going to be 2y. Since I just took the derivative of y squared, I'm going to have dy over dx. Okay. All right, now this is useful because now what we got to do is we got to look for the dy's over dx's. So there's a dy over dx right here, and there's a dy over dx right here. Now we can't just subtract this over because you have this term being multiplied by it. So I'm going to distribute this to both terms. Okay, so what I'm going to get is the following. I'm going to have this 2x cosine y. And then this is going to give me negative. Let me put the x squared in the front, sine y. And then I'm going to write just dy over dx here is equal to, now I'm going to distribute this. So this 2 is going to cancel out with that 2. So I'm left with x times x squared plus y squared to the power of negative 1/2. And then plus, now this 2 is going to cancel out this 2. So I'm going to have y x squared plus y squared to the power of negative 1/2 times dy over dx. Okay. All right, we're almost there. All right, so now let's move everything that doesn't have a dy dx. So this one doesn't have a dy dx. So let me move this over. X times x squared plus y squared to the negative 1/2. Let me move that over. Okay, so now that's gone. All right, so let me move a little lower. So this is going to be 2x cosine y minus x squared plus y squared to the power of negative 1/2. Then we have this minus x squared sine y dy over dx is equal to y x squared plus y squared to the negative 1/2 dy over dx. All right, so now let me move everything that had a dy over dx over. So I'm going to add this term over, plus x squared sine y times dy over dx plus x squared sine y dy over dx. Okay, so now that's going to go away. So I'm left with 2x cosine y minus x squared plus y squared to the negative 1/2 is equal to y x squared plus y squared to the negative 1/2 dy over dx plus x squared sine y dy over dx. Okay. Oh, all right. So now let's take this because we got to factor out this dy over dx. So I'm factoring this thing out, and what am I left with? So I'm left with a big mess. So I'm left with y times x squared plus y squared to the negative 1/2 plus x squared sine of y. That's going to be on this side. And on the other side, nothing's really happening. 2x cosine y minus x squared plus y squared to the power of negative 1/2. All right, now let me isolate the dy over dx by dividing this term over. So I'm going to divide by y x squared plus y squared to the power of negative 1/2 plus x squared sine y. So both y x squared plus y squared negative 1/2 plus x squared sine y. And then, whoops, so this cancels out. So now I'm finally left with this dy over dx. So dy over dx is going to be equal to all of this mess. 2x cosine y minus x squared plus y squared to the power of negative 1/2 divided by y x squared plus y squared to the power of negative 1/2 plus x squared sine y. Oh, this was a big mess, but we finally finished it. Don't try to change the negative exponents. These are really complicated. So usually I would prefer if you put it to the bottom by making it positive, but just leave it as is. This will be, it's good algebra to work with because what you really want to do is just get dy over dx by itself. But that was just it. So it was one problem that was a little bit, that was not as bad, but the second problem was a little bit more harder. But it's useful so that because it makes you use the product rule and also the chain rule at the same time. Okay.